Dear students, I hope you are doing well. Previously, we have made two videos. First video on basics of thermodynamics. Second video on thermodynamics variables. Third video we are going to make on thermodynamic work done calculations and also IUPAC sign convention for heat and work. So heat and work. Heat and work. Let us see that. So thermodynamic work done calculations we are going to see, and first of all we are going to see IUPAC convention for heat and work. IUPAC means what? International Union and Pure Applied Chemistry. IUPAC means what? International Union and Pure Applied Chemistry. Let us see. Yeah. This is a system. This is a system with gas or anything. Okay. System. So that system loss heat. Heat is represented by Q. Yes. Q is equal to, this is volt. Q is negative. Right? Q is negative. So according to that, system loss heat. System loss heat. Heat loss by the system. Then one more system we are going to see. System gain the heat, right? Heat is gained by the heat. So this is the system. Heat is gained by the system, right? System loss heat, and here system gain heat. Here, so this is Q is equal to what? Positive, right? So the system which loss heat or temperature, the Q is equal to negative. If the system loss heat or temperature or energy, definitely that Q is equal to negative. Then the system gain the temperature or heat or temperature, so that Q is equal to positive. So this is the system. This is the system. The system which loss temperature, which is represented by Q is equal to negative. If the system gain the temperature, the Q is equal to positive. Next, sign convention for the system. For the system. Yeah. See that. Just previously, just now we have seen positive sign of the system, negative sign of the system. Okay. If the system lost temperature, the Q is equal to negative. If the system gain the temperature, the Q is equal to positive. Okay. To prove that, we are going to see particular examples. Suppose to say here, this is a cylinder. This is a cylinder. Up to here you have to take a gas. Here, up to here you have to take any gas. Right? Now, the gas exerts some pressure towards up. Right? towards up. Then what? The volume of the gas increases. Up to here, the volume of the gas increases. Here, increases. Okay, this is the system. Right? Now, work done by the gas or work done by the system, let me write gas or work done by the system. Okay, W is equal to negative sign. This is very, very important. Then go for another example. Here, this is a system. Okay. Up to here, you have to take the gas. This is the gas. This is the gas. Right? If you arrange a piston on over the gas, this is the piston. This is the piston. Right? Piston exert the pressure, then volume will be decrease. The volume will be slowly decreases. So here up to here the volume will be decreases. So V volume decreases by exerting the pressure. By external pressure. So work done on the system, right? Work done on the gas. Let me write here. System or work done on the gas. So W is equal to positive, right? Yes. Okay. So this is sign convention. So work done by the system, work done by the system, work done by the gas is W is equal to negative always. Next, work done on the gas, work done on the system, right? This is the piston exert the pressure, so that's what volume will be decreases. So what this is the volume will be, V will be decreases. So V should be decreases or V will be decreases. Okay, so volume decreases by external pressure. So pressure is applying externally by applying piston on over the gas in the cylinder. So that's what work done on the system or work done on the gas is positive. So W is equal to positive. Is it clear, everybody? Yes. So positive and negative signs we have seen. Okay. So now actually very important point. This is the note for everybody. No positive and negative signs. This is just for magnitude of work. This is just for magnitude of work. Actually, there is no positive and negative sign, right? Just magnitude. It means about direction of the movement, the direction in which that work is done, right? Yes. Let us see here. Next one. Reversible process. Reversible process. Actually, what is the reversible process? We are going to see some examples. This is the system. This is the system. So with gas, this area is filled by complete gas. So what kind of gas will be filled? Yellowish. Then see. So here, this is external pressure which is exerted by the atmosphere, right? Then here this is external pressure. Then simply you have to keep small stone here. This is the small stone, small weight. So step by step, this is the gas. See now, the gas as pressure is little bit less than the pressure of atmospheric, right? The pressure of atmosphere is little bit more than the pressure of gas inside the cylinder, because of small weight was kept on over the gas along with the piston. So that's what slowly the piston will move inside, so that slightly the volume of gas will be changes. That is what decreases. So here we can write it. What is that? Here P external minus P gas into, right? So this is the what? This is equal to dP. Okay, this is equal to what? This is equal to dP. dP means here, let me write here V. So dV is equal to, dV tends to 0. It means what? Pressure external minus pressure of gas is equal to dV. dV means what? Small change. The small change will be happen under the reversible process only. So it required many steps. Yes, reversible process required, okay, infinitive steps and infinite time. Infinite steps and infinite time. So that process will be proceed very slowly. This process required many steps, right? So here P external atmospheric pressure, pressure of gas, that is equal to dV. So that dV means for small change in the volume, so that slight difference takes place, right? So we can write it here one more we can write it. So according to that, here, and force pressure equal to F by A, right? Instead of pressure, the F force will be used, right? So now we are going to write this, the pressure external means what? Driving force, we can write it. Driving force minus opposite force of gas. Opposite force of gas. Opposite force of gas. So the driving force is very small. Very small. Very small means what? Very small change is represented by dV, right? So reversible, in that reversible process, so system was taken with gas. So on over the gas, piston was arranged and a small weight also arranged. So piston tried to move inside the gas with external force as well as little bit weight was there on that. So that volume of the gas will be slightly decreases. How much decreases? It will not be calculated. So that is a small change will be denoted by or represented by dV. So P external minus P pressure of external pressure minus gas pressure is equal to dV. dV tends to approximately 0, negligible. So we uncountable means what, we cannot calculate that much amount of slight volume will be decreases. So these are the point you have to represent. Yes, irreversible process. Yes. Now irreversible process is slightly opposite of reversible process. Here same system was taken, right? This is the gas, right? So that piston was arranged. Along with piston, this much, just what big size weight was arranged. So we kept a little bit weight. More weight was kept. Weight. This is more weight. In this case, what driving force or external force is more than the force of gas. The force of gas. So that's what the piston will enter into the cylinder. Then the volume of the gas will be decreases. Up to here, the volume will be decreases. Right? Volume will be decreased due to external force. Due to external force or external pressure. Due to pressure external. Right? So that's what it required a finite time. Okay? Finite time, finite steps. Okay? It required first one. Finite time and steps. Right? Now let me write on the board. So here and pressure external minus pressure gas is equal to delta P or delta V. So we can write it delta V. So more amount of volume will be decreases. So here V1, then this is the V2, right? So due to that arrangement of more weights on over the gas in the cylinder, so that due to that more weight, the piston will enter into the cylinder, then volume of the gas will be decreases from V1 to V2. Then how much volume is calculated? Yes, that will be calculated. Instead of this, it will be written as R P external minus P gas is equal to, yes, delta V, nothing but, and V2 minus V1. So which is represented by delta V. Right? So now here let me write based on the, yes, with the help of the force, because of is the pressure is equal to F by A. Right? Is the pressure is equal to force by area. Right here, driving force nothing but external force. Right? Driving force force minus the force, opposite force of gas. Force of gas. Force of gas. In this case, what? Driving force is large. Driving force is large. You try to understand. Is it clear, everybody? Dear students, just now we have completed reversible process and irreversible process. You practice each and every formula and try to keep in mind. Then share the video, like it and subscribe. Thank you. The continuous video will be come tomorrow. Thank you.